Alright, last lesson of the chapter. Our last lesson expected us to use trial and error to find factors and solutions. Luckily, most of the problems we had gave reasonable amounts like 2 or -1. Remember I told you before, or what we had on the last lesson was that all your first solutions that you found were within this range of -3 to 3. But, a few questions. What if the first factor that you would find was -23? What if it was 1.5? What if it was 3/5 or something like that? How much time would we waste just blindly kind of doing that? And last question, what if we could narrow the options down somehow? Well, the good news is we can. So what the thing is you're going to be asked to solve these things on your own. And again, on the work I gave you so far, you've either been given zeros or given solutions to kind of push you along the way, or I've made the solutions reasonable. But you never know what's going to happen. So what we need to do is find a way to kind of solve these things no matter what. And we would not need any kind of hints. So when given a polynomial, we can determine what the possible rational zeros are. Again, doesn't mean all of them are, but the possible numbers, by focusing on the leading term and the constant. So for the following equation, state the possible rational roots. This is something you'll be doing on your homework. So again, what we look at is the leading coefficient of 3 and the constant of 15, and we take the factors of each. The factors of 3 are 1 and 3. The factors of 15 are 1, 3, 5, and 15. Those are the numbers that go into 15. And what we are going to do is we're going to take each of these bottom numbers, so the 15, the constant, and put them on top of each of the factors of the other numbers. So 1 over 1, as well as 1 over 3. So again, 1 over 1, 1 over 3. Then we're going to do the same thing with this. 3 over 1 and 3 over 3. And then 5 over 1 and 5 over 3. And then 15 over 1 and 15 over 3. And each one of these has a plus or minus attached to it. I just don't write those because it kind of is a little bit more writing than I want to do, especially when I'm just listing the numbers. But when I go to simplify these numbers, which is the next step, I will put a plus or minus. So here 1 over 1 is 1, so plus or minus 1. 1/3 is 1/3. 3 over 1 is 3. But here's where you need to be careful. 3 over 3 is 1, which I already have on the list, which means that's not necessary. That's a repeat. 5 over 1 though is 5. 5 over 3 is a good number. 15 over 1 is 15. And 15 over 3 is 5, so that is also a repeat, which means this is actually the list of numbers that you can potentially have that work to divide into this polynomial. Now I know it looks like a lot of work, but let's think about this. Without this list, there are millions of numbers that you could check. With this list, you've narrowed it down to 2, 4, 6, 8, 10, 12 numbers, which is a lot better than what we initially were working with. Now on the computer, again, make sure you're listening to this. On the computer, you don't type this in. You'll type in 1, -1, 1/3, -1/3, and so on, pretty much all the way down the list. So again, when you go to answer that on your computer, just make sure you list it this way. But again, in terms of your listing it that way would be just fine if you were doing this on paper. Unfortunately, we're doing this on computer. For the following equation, state the possible rational roots. Again, same situation. We're going to look at the front number of 5 and the constant of 65. The factors of 5 are 1 and 5. The factors of 65 is 1 times 65. 2 doesn't go, 3 doesn't go, and I know that because 6 and 5 is 11. And if 3 goes into it, the sum should be divisible by 3. 4, no. 5, I believe, goes times 13. Yep. 6, 7, 8, no. 9, no. 10, no. 11, no. 12, no. I believe it's just a very simple 1, 5, 13, 65. Now, if I were you, I'd be more careful, but fortunately, I did this video already, and it just so happened to mess up at the very end. So I do know those are your factors. But again, what we're going to do is take these numbers and put them over those numbers. So 1 over 1, 1 over 5, 5 over 1, 5 over 5, 13 over 1, 13 over 5, 65 over 1, and 65 over 5. And again, the actual list that you have would be the simplified version, which that's 1. That's 1/5. That's 5. Again, that is 1, so no. That's 13. 13/5 is right. 65 is right. And that, I believe, is 13. Actually, we just did it. It is 13, so that's a repeat also. So again, this is your list of numbers. But again, when you type these into your computer, you got to type 1, -1, 1/5, -1/5 with a comma in between, and do all that way. So with this new tool, you'll no longer be given any solutions or factors. You have to use these possible roots to start your problem. Remember that in the overall grand scheme, you don't need to find 4 roots. You just need to find 2, because it's an x to the 4th problem in this case. So when you find 1, it breaks down to x to the 3rd. When you find a second, it breaks down to x squared. And from there, we can either use the quadratic formula or we can factor, which is what this is talking about here. As this is the level of expectation your future classes would have, after this chapter, you should be able to find any solutions of any polynomial, no matter how complex it may look. Again, that's any polynomial at all, because you now have this skill. Now, what you'll notice as we look at the last problem of the day is that it'll take some work, but again, the fact is that you can still at least figure out what's going on without needing to use anything that's kind of illegal or cheating in any way. You'll actually be able to figure out what the answers are on your own and get those things done. So, final question of the day is find all roots for the given expression. And so we know, well, the good news is there's no fractions because our leading coefficient is 1, so everything is just going to go over 1. So there's no need in using that because, again, the factors of 1 is just 1. But our other number is 15, 12, which is kind of big, and I think I'm going to use a factor tree to do this because I don't want to make a list that I don't know how big it's going to be. So 1, 5, 1, 2 is my number. I know that 1 and 15, 12 is it. I'm pretty sure 2 goes in there also, which is 756. 3 is 504. 4 is 378. These are some ugly numbers. 5 doesn't go because if it was a 5, it would end in a 5 or a 0. So let's try 6. 7. All these numbers go. This is a mean one. 8. And 9. I'll stop at 9. And I'll tell you why I'm stopping at 9 in just a second. What I will do is put some 3 dots here. And those 3 dots mean the same as they've always meant in your notes, which means that there might be more, but we're not sure. The thing is, if we're looking at doing just testing these numbers, why do I want to take 20 minutes to make the full list of numbers when all the numbers might just be right here in the screen already? So what I will do is I will try all these numbers, and then if I run out, then I'll try 10, 11, 12, 13, because again, there's no need in working forever on that factor tree because I don't really need all the numbers. I just need a series of numbers. So again, 1 over 1, 2 over 1, 3 over 1, all those are going to be my numbers. So again, now we just start our quest. And again, you have to have an ability to fight with this, because if you do not, you're not going to get through it. But all we are doing now is checking this out to see if we get a 0. So 1, 1, 7, 7. I think that's, well, I'll be careful here because you don't want to mess up. 73 minus 7 is negative 66. Negative 66. Here's the thing, use your common sense here. That and that is going to be maybe 300 something. Negative times 1, which is negative 3 something. 1 is not it. So we're going to try negative 1. So again, all you're doing here is just taking what you know, and we are seeking for the number. We're looking for the number here and hoping that a number works. 1, negative 1, 5, negative 5, negative 78, 78. And again, I'm going to stop, because using common sense, this and that is going to make a smaller negative number, which I'm then going to multiply by 1 to make a positive number, which is obviously not going to make 15. Because remember, in order for this to be 0, I need a negative 15, 12 here, so that's not going to happen either. So 1's not it. What about 2? 1, 6, negative 73, negative 246, and 15, 12. 8, 16. If you wonder why I don't type negative 73 plus 16, it's because I don't care about that part. I just need the actual number. So 57, because I can use my common sense on that part. This is going to be a negative 114. Again, I don't think that's the case because half of 5, you're going to multiply by 2. And half of 1512 is 7 something. This is only 3 something, so I don't think that's going to work either. So again, I'll just finish it off. So 246 and 114 there. And then if I multiply that by 2, I don't get 15 anything. It's just 7. So 2 doesn't work. What about negative 2? 1, negative 2, 4, negative 8, negative 81. Looking good. Oh, not looking good, because that would be positive 162. And again, using your common sense here, positive 162 is going to lead to a negative 100 something. I don't even know if it's 100 something, but let's say about a negative 100, which times negative 2 isn't even going to give me what I need there. So negative 2 doesn't work. And this is really where the work is, and this is why I tell you that you have to love what you're doing, because in order to have the ability to go ahead and fight through questions like this, it does take for you to actually care about finding the answer, which is why I always tell you that if you don't really want to be in this class, you might want to consider getting out, because it's only going to get worse and worse as you move forward. 3 times 9 is 27. Negative 73 and 27 is negative 46 times 3 is negative 138. Looks decent. 138, let's put minus 246 because I need them to work together. Makes negative 384, and I don't think that's going to work because 3 times 3 is 9. So yeah, that just breaks my heart. We're getting close though. 1152 and 1512. Let's try negative 3 and hope that works. Here we go. 1, 6, negative 73, negative 246, and 1512. 1, negative 3, 3, negative 9. Make sure. 1, negative 3, 3, negative 9, negative 82, positive, actually that's positive 246. Which means I don't think that's going to work either, because that's just going to bring me back to 0, which is then not going to make 1512. So negative 3 is off the list also. And what I'm doing here is just crossing them off so I know as I go. So again, what I said about not wanting to be here is more for people who have not exercised the ability to even do what they're supposed to do on the general basis. If you don't think you can even do homework or want to study, it's going to get tough. 1, 4, 10, 40, negative 33, 132, so negative 132, adding 246 makes 378. This is actually looking nice. Let's see what happens if we multiply by 4. Look at that. Whew. So 4 works. Okay. And here's where your strategy comes in, and here's where good notes will help you out while you work through it. Write this down. You want to check a working number until it does not work. And what that means is, if 4 worked once, it could also work twice. Think about the problems where we had factors of x plus 2 times x plus 2. Notice that negative 2 actually has 2 different instances in that factor. So you can actually have more than one instance of 4. So what we want to look at is maybe 4 works again, because if you skip over it, what if 4 was the only factor through the whole thing, and you check all those numbers on this list, and all you had to do was keep checking 4 and 4 and 4 and 4. Another thing you want to make sure you do is once 0 works in all this work that we have on paper, notice I'm crossing off the numbers that don't work, and I circle the number that did work. I would do that because at the very end you need to find out what numbers worked and what numbers did not work. So we are going to try 4 again. And again, hopefully you wrote the note, but the reason we try 4 again is because it could happen more than once, and we don't want to leave it behind until I guess till we've squeezed all the juice out of this fruit. So if 4 gives you one answer, keep going until it doesn't work. So 1, 4, 14, 56. What is that? Negative 23. No, 23. And then 4 times 23 is not what I'm looking for. So 4 is off the list, although that 1, 4 did work. And this is why you need to make sure you love it, because again, we are on our second paper. So using these numbers again, 1, 10, 33, and 378. And the reason you want to be careful is because if you copy that number wrong, well, you end up saying that it doesn't work when it actually might have worked. We did not try negative 4 yet, so let's do that one. 1, negative 4, 6, negative 24, negative 57, which is, again, breaking my heart, 228, not 378. So negative 4 does not work. And here is where the list actually helps. I'm done with my 4s, but I would have checked 5, but this list says that 5 is not even possible, so we'll jump straight to 6. So 6 here, 1, 10, negative 33, negative 378, 1, 6, 16. I believe that is 96. Yep. Then 36 or 96 minus 33 is negative or 63. And 63 times 6 is, hey, good news, is 378, which means that 6 works, and I circle it. Now remember, we started out with a power of 4. We found one number, which meant we were down to a power of 3. We then found a second number, which means we are now down to a power of 2, which means I'm not going to use synthetic division anymore. I'm going to put it in expression form and either use quadratic formula or factor to solve this, and I think I can actually solve it. Numbers that multiply to be 63 and add to be 16. The only numbers I know that make 16 and be close to that isn't 7 and 9. 7 plus 9 is 16. Remember that because that's a regular x, I can do x plus 7, x plus 9, because remember this was equals 0. X plus 7 equals 0. X plus 9 equals 0, which means my last two numbers are negative 7 and negative 9. Now, oddly enough, look at what else was on this, a 7 and a 9. So that possible list did work, we didn't need all those other ugly numbers that were there. And so your final answers would be 4, because again, that's where it helps to find this here. We know that 4 worked, that's why we circled it. We know that 6 worked, that's why we circle it. We know that negative 7 works, and we know that negative 9 works. And that would be that. Alright, so again, it is going to take some love for you to do that. Again, this is where I kind of see the students who really want to do this stuff separate from the students who are just kind of here because, you know, they're either forced or some other reason. But anyway, the test will be made available on Friday. Be sure to use the rest of this week to prepare. Again, your pre-test should be available already at this point, so remember that if you can get your percentages up to 90% for all the assignments by Friday, you have access to the pre-test. Again, you should have access to it once you have a 90% on all of them now, but again, it does close on Friday because it is a reward for those of you who are ahead of time, not those of you who wait until the end to do your homework. So good luck. Again, send me the questions that you have, and I will talk to you later.